Okay, welcome to our talk on chaos testing with the autonomous operator. I'm Patrick Stevens. I'm a senior software engineer working on the Couchbase Autonomous Operator in Couchbase. I started this year in February, but prior to that, I've got about 20 years of experience primarily in the defense industry, where we have a lot of chaos and maybe some engineering. The other presenter will be on shortly is Rue Thorpe. He's a software engineer in the same team. He's working in the quality engineering side. And we've also got a GitHub repo with all the examples and demos and stuff we run in this presentation, and that's linked there. And we've also got some slides at the end that just have all the links and references in case anyone wants them. So what are we going to talk about today on our chaos engineering talk? So Rue is going to do a quick intro to what chaos engineering actually is. This is quite a large topic, it's fairly recent as well. So he's going to cover what it is, give you a little bit of a flavor of chaos engineering and how it all fits together and potentially why we'd want to use it. I'm then going to move into what requirements we have at Couchbase, what we need our chaos engineering to do. I'll then give you a nice little review of some of the alternatives we've considered along with the one we chose and a little demo showing you a flavor of each. And then Rue's going to do some more detailed sort of breakdown of our testing and more detailed demo of the specific tool we're using as well. And then Rue will also talk about some of the future work we're doing, some of the customer issues and stuff we're hitting and some of the ideas and what we want to do next. Mm-hmm.
Okay, so I'm just going to quickly cover what chaos engineering is and kind of the general use cases behind it, why we do it and what it's good for. So if we go on to the next slide, I've got just a dictionary definition there, but generally the gist of it is we're just breaking things to make sure that the system as a whole can handle it and recover properly. Breaking it in a controlled way, an intentional way, whether it be in a production environment or a test environment, to emulate things going wrong in the real world, and kind of accepting that you're never going to reach a point where you'll have 100% uptime. So planning around things crashing, network issues, things like that, and making sure that you can recover from that and that everything continues to work properly. This generally, I think, is considered to have started at Netflix in 2011 with a tool called Chaos Monkey, which at the time just crashed virtual machines that they used. But this has grown out to be a plethora of tools, which Patrick will touch on later, that do all sorts of things, creating network issues, network partitions, packet loss, crashing Kubernetes pods, crashing containers, bringing down VMs, adding stress to CPU or memory, things like that. And generally it's very helpful. It's great for finding bugs. It's just another form of testing. It's fantastic for improving the resilience of an application. It greatly reduces the amount of unplanned downtime and unplanned outages because it lets us plan ahead for those sort of things, and we know what's going to happen if things crash or things go down or issues arise. And it lets us determine what's called mean time to recovery. So if something does go wrong, we can accurately predict how long it will take to recover from that and to get back to a good operating standard.
Okay, so I'm going to talk about what Couchbase needs. So what are our requirements basically from our chaos engineering tooling? So what must it support? So these are sort of the must-haves. So we are deploying this as part of our longevity testing. So making sure stuff keeps running when bad things happen and just for a long time as well. So we want to make sure that the operator stays robust. So there's pods that run the operator. So we want to mess with those in different ways and make sure it keeps coming back up and it carries on running. We also want to make sure the Couchbase server cluster is resilient. So if we mess with pods, if we destroy pods, if we do network things to pods, the operator can recover them and make sure your database stays running. We also need to consider how we monitor and verify it. So we've got a monitoring and observability stack. So that's what CMOS stands for, Couchbase Monitoring and Observability Stack. So it's integrating that and making sure we generate alerts and stuff as necessary. So it must support some level of pod disruption, killing, resource constraints, those kind of things. It must deal with network errors and latency issues, because this is a big problem that's very difficult to reproduce. And resource throttling as well. What happens when we start messing about with the pods, with the individual containers, when we throttle all the different bits, how does it mess with things? So that's what we're looking at there. What would it be nice to have if you know, a tie break for some of the other solutions? So this needs to be, you know, integrated with our CI/CD automation. So it needs to be using GitOps. We want simple integration with Kind, so Kubernetes in Docker, because that's what we use primarily for a lot of our testing. OCP and GKE as well, if we can. Declarative and automated from the CNCF is the ideal thing we want. And also, does it support some kind of customization for Couchbase? You know, can we extend it in some way to do Couchbase specific stuff? So yeah, there's like Pillowfy and the workload generator. Can we integrate those into the Chaos Engineering tool? Can we get the Chaos Engineering tool to hit some of the REST APIs or interact with Couchbase in some particular way? Can we also use it outside of Kubernetes? So Kubernetes is obviously the focus of our team, but there's a huge amount of Couchbase deployed on premise in the cloud, not using Kubernetes. So we don't want to reinvent anything for different deployment types. So it would be very useful if we can use one tool and deploy it on premise, in the cloud, in Kubernetes. You know, we've got the same testing. We don't have to rewrite testing for a different framework. And we can just, you know, extend tests. We can deploy one Chaos Engineering tool and just keep adding to it for the different environments as and when we need to. So those are kind of the tie break things that we would like to have for ourselves. I mean, I touched on the CNCF one. Primarily, you know, that's a good one for open source and making sure it's fairly mature and stable and industry standard as well. So that's why we've gone for those kind of things. Right. So what options are there? What options do we have in the technology space as it stands? And this sort of section covers a quick overview of some of the alternatives, and then I've got a nice little demo showing you how they all work, kind of thing. So there's quite a lot of Chaos Engineering tools. There's probably hundreds if you start looking. Some are very bespoke, some are very dedicated to one particular area. And so to simplify things, we just went with what's on the CNCF landscape and what's a mature level, i.e. incubating or above. And there's really only three alternatives there. So the alternatives are Litmus, which is a very mature thing. It's been around for quite a long time. It has a load of platform-specific examples as well in its sort of marketplace approach. But it did have quite a bit of faffing to get working with Kind, I found. And it's quite a verbose setup when you want to use the deployments. It's based on using Argo workflows. So if you're already using them, great, but we're not. So having to transition and do all that stuff, it didn't work very well for us. The other one we sort of looked at and didn't continue with is Chaos Blade. So there's an operator for Chaos Blade. It's all very immature, though, I'd say at this stage, which is a bit of a concern. There's no Helm deployment in a registry. You have to pull it from GitHub. It's got quite good sort of ideas about what it wants to do in the future, but again, kind of the flux and how that all works is a little bit concerning. You know, if we implement something now, is it going to change 2 days later? So what we actually went with in the end was something called Chaos Mesh, which is something I came across at KubeCon this year. There was a good talk on it for the EU KubeCon. Using it, I think it might have been on the Fluentbit side, I can't remember. So this is the tool we've gone with. It started out as a Kubernetes deployment only, but actually, and that was one of the things touched on this year at KubeCon, was there's on-premise options now as well, so you can run it as a daemon on-premise if you want to deploy it that way. So that kind of sorts our use case there a little bit. It's got a nice dashboard, so Litmus has a dashboard as well. Chaos Blade, the operator, doesn't. It's all driven by CRDs. But Chaos Mesh, you've got the dashboard, you can create everything, export it, and then automate that from that point onwards. So that's quite nice as well. And there's also a fully offline deployment. If you want to run it in some kind of offline domain, financial, defense, healthcare, those kind of things where maybe you don't want to run some of these toolings. And it was quite simple to get going. This was probably the easiest one to get going out of all three. So again, that kind of encourages us a little bit that, if it's easy to get going, it'll be easier to use moving forward. So I'll show you a little demo of all three now. Right, so here's a quick demo of using all these different tools, and this is all in the Git repo. So first of all, I'm going to create our Couchbase cluster using the operator and kind. Actually, what it does is create a kind cluster, as you can see, and then we use the Helm chart to install various other bits and pieces. Now we're going to move on to Chaos Blade. So the first one, which, as I say, doesn't really have a dashboard, so it's not very exciting, but it will show you how it works. So this just uses the sort of offline Helm chart to install it all. You can see there's a few warnings as well about deprecation because I'm on the latest version of Kubernetes at this point. And then it's all up and running. Most of these things are pretty straightforward to get going. Sometimes there's a bit of faffing as well, but this just shows you kind of, there's a CRD for the Chaos operator, but that's all it is. Now we move on to Litmus. So Litmus is much more straightforward. Just add a repo and install it from the Helm chart. There's a bit of extra stuff at the end for kind port forwarding and maybe sorting out ingresses, egresses, which was just a bit frustrating. So I use the Helm chart. There's some default credentials we can log in with. Again, you could configure that in the Helm chart. And this is kind of the dashboard you would see in Litmus. And it can integrate with the marketplace and a few other bits and pieces like that. There's a nice link out to the docs, which is useful as well. But again, this is not offline, so that might be a concern for people. And then we'll move on to a bit more detail about Chaos Mesh, which again, simple deployment. Just following the quick start guide effectively. There's an install script for kind. There's also a Helm chart as well. I'm using the get it going as a test mode, so you get full admin credentials and stuff like that. So deployed it, done the port forwarding. Here's the dashboard coming up. And you can kind of see, similar to what Litmus has, there's various bits and pieces. They call them experiments for breaking things, tutorials, workflows, all these kind of things, scheduling. So it's pretty full featured. It looks really nice. It's quite straightforward to use. And you can kind of see all the pods running over there as well. So here we're going to mess about with triggering a specific failure on one of the Couchbase pods. So separately, I've started up Couchbase in the background, running. Again, the scripts are in the repo, but there's a couple of Couchbase clusters running 1, 2, and 3. And they're all in their own namespace just to help things out. So yeah, we can say, okay, kill some, in this case, we're going to do a pod failure. But let's select something. You can select based on labels, and there's lots of options for how you want to select things. In this case, I've just selected a namespace, but you can see all those labels are basically auto-discovered from what's on the Couchbase pods as well in that namespace. So there's quite a few there. So you could have your own ones as well. And then you can even then just go, oh, this is the ones that might be targeted. Actually, I don't want to kill the operator pod. I could have done that through labels as well. But yeah, I'm just doing that. There's the pod, so you can keep an eye on it in the demo for what it's doing. There's the operator log, just showing you what the operator sees, kind of thing. And then we just give it a name and tell it how long to run for. You can have it running continuously, or you can say just run for a minute, 2 minutes, whatever. In this case, we'll do a pod full, but you can see there's plenty of other options as well there. So when we hit submit, it basically creates the experiment and runs it, which doesn't take very long. But you can see the YAML there as well about that's the kind of stuff we'd export and then import. And you can see the pods actually fallen over, and then the operator sees that log as well.
Yeah, so I'm going to quickly cover why and what we're doing, and the sort of issues and things we're looking for when we're chaos testing with Couchbase and the operator specifically. So it's as you'd imagine, we try and emulate basic Couchbase operations. In this case, just like creating, reading, updating, and deleting documents. Check that that's continuing to happen as we inject chaos. And then, as mentioned earlier, and as Pat showed, crashing things, creating chaos and stuff, and making sure that both the operator and the Couchbase server pods continue to work properly. And then using the CMOS stack we mentioned earlier, observing and recording any of the results and grabbing the logs and any errors and that sort of thing, so we can keep track of any of the issues. The benefit of Chaos Mesh and many of the chaos testing tools, it lets us very easily reproduce issues, whether they be stuff we've seen before or stuff customers have seen before. So it means, for example, we've had issues with customers having network partitions and pods failing then, and we can reproduce that very easily with Chaos Mesh. All right, so already set up here, as Pat covered earlier. So we have a Couchbase cluster with the admission controller, the operator, and 3 Couchbase server pods. And then in a separate namespace, we have Chaos Mesh, which the manager, the daemon, and the dashboard. So that's all set up and ready to go. And then just in another tab over here, I'm just port forwarding both the Couchbase UI and the Chaos dashboard, just so we can more easily see what's going on. So here's the Couchbase UI, the usual thing, and all 3 of the pods we mentioned earlier. And over here, the Chaos Mesh dashboard, as Patrick talked about earlier. So there's all these different faults here, and I kind of touched on the various faults you can do earlier on. Pod faults, you can crash pods and containers and things. You can create Linux kernel issues, various issues with networks, partitions, packet loss, delay, so on and so forth. Issues with I/O, latency, and faults and things like that. You can stress test the CPU and memory. You can do clock skew, so different pods have slightly different times. And then if you're using AWS or GCP, you can create issues with EC2 or compute instances, reset them and stop them and that sort of thing. But for this, we're just going to do a pod fault because it's quite apparent, quite easy to see. So you saw Patrick do this earlier, so you can pick what scope you want. So in this case, just the namespace I've created Couchbase in. We can pick a label. So in this case, I can just pick the Couchbase cluster, which means it'll only hit the Couchbase pods. It won't hit operator or the DAC. We'll call it something just pod fault. And then we'll just run it for 30 seconds. You can run it continuously if need be. Fire that off, and then hopefully when we go over here, you can see that it's created a fault in one of our server pods, and that'll continue to happen for 30 seconds. The operator manager, you can see here, if we do get pods again, the pods down, and the operator will, as you'd imagine, start to bring that pod back up, and then. So if we go back to the Chaos dashboard, we can make another one. In this case, we just kill the pod. So rather than a failure, we just kill it altogether. In this case, we'll do it on Couchbase again, but this time we will do it on the operator and the DAC instead of the Couchbase pods. And again, we can just we can call it something. So now if we take a look here, once we've run it, you can get the YAML here. Patrick touched on this earlier, but this means we can grab the YAML for something we've made kind of intuitively through the UI and make use of that in CI/CD and GitOps and things. So that makes it very easy to reproduce and use this in automation and stuff. And then separately over here on the left, there's schedules as well, which just lets you set up cron jobs for certain chaos. So it's exactly the same. All the same faults that we've done, but just this time you can set up a schedule for it to run on. So if you want to kill pods or create network latency every hour, every week, anything like that, it's very useful for doing that. And then there's also workflows. Workflows are pretty interesting. They let you serial or in parallel run multiple experiments, and you can even run workflows within workflows. And this, as you can imagine, lets you build out a much more comprehensive chaos test. So if here we set something to run for an hour, and then within this, we can just run the same thing again. Run a workflow, set up some pod faults or some network issues, partition, and we can run all of these things in parallel or serially, and it'll output to a YAML file again, which means we can very easily replicate it and run it in CI/CD. Okay, so I'm just going to cover the stuff that we've planned and we'd like to do in future and the improvements we want to make. So some of them are pretty obvious. So at the moment, we just kind of run this with a tool called Pillowfight, which lets us inject or create documents en masse, and a tool called CB Workload Gen, which is pretty similar and lets us simulate read and writes, but expanding this and extending this so that we can do various operations from the SDK or set off rebalances while we inject chaos, scale up and down the cluster, that sort of thing would be fantastic to test. As Pat mentioned earlier, at the moment, we do a lot of our testing on Kind, but we also test on various cloud platforms. And as you saw in the demo earlier, there's chaos for AWS and Google Cloud, which means it'd be great to extend and test what happens when we start injecting chaos on that. Currently, our test automation for our regression testing happens mostly in Jenkins. So including all of this process and building it out into a Jenkins pipeline and integrating it with our current regression testing would be a great way forward to further automate this. And as I mentioned earlier, Chaos Mesh lets you output everything as YAML, so it's very easy to automate. And in some places, we also make use of GitHub Actions, and Chaos Mesh has integration with GitHub Actions, so you can very easily do that as well. Another thing we mentioned in our requirements was the extensibility of the tool, and Chaos Mesh does let you kind of custom make chaos. So in the future, making Couchbase specific chaos would be very, very helpful, and letting us create issues with Couchbase itself and test how the operator deals with that, especially while other pod issues or network issues and so on and so forth. And also alongside the core operator, we also have various sidecar components for backup functionality, Prometheus exporter, a log forwarding with FluentBit, and extending the chaos to make sure that functionality with those sidecar components continues would be a fantastic next step as well.
Thanks for joining us for this talk. Here's just some contact details and the GitHub repo that's got all the details in. So some of those scripts you saw being run before are all just in that repo. Thank you, and a big Q&A now.